I was walking past a river a while back and I wondered what the formula would be to calculate the flow rate. This is what I got, and it turned out that I found this same formula on Google, so it was nice to verify that. But I'll go ahead and explain the formula. Let's take a square pipe because I think all pipes are square. And let's take a cross-sectional area, which will be 1 meter by 1 meter, and then the length will be 10 meters. This pipe will contain water or some sort of fluid, and we want to know how long it will take for the fluid to go from this point of the pipe to that point of the pipe, because we want to move this entire volume a certain distance. Length times area equals volume. You can say meters times square meters equals cubic meters. You just add your exponents. But we don't want volume of cubic meters. We want flow rate, which would be cubic meters per second. So if we just add a second right here and we have cubic meters per second on this side of the equal sign, then that means on the next side of the equal sign, we have to add a second either underneath the square meters or underneath the meters. If we put it underneath the meter right here, we get a velocity, meters per second. So if you have a river or a pipe or something right here and you just float something in the top right here and then time how long it takes to cover a certain distance, you can just take velocity times your area and that will give you the flow rate. In this case, 10 meters per second because it covers 10 meters in 1 second, that object that we floated down. Multiply it by the area and we get 10 cubic meters per second. I checked on Google and they said if you're doing something like a riverbed or a creek bed, you can take a whole bunch of different depth samples to get an average depth for an average cross-sectional area of your river. Or I suppose if you happen to notice that your banks are angled at 20 degrees or something like that, I suppose drainage ditches can look like that. Then you can just use some simple geometry. In reality, there is a little bit more complication to this formula because the water flows at different rates at different parts, because the water along the bottom of your creek or your drainage ditch or the water along the sides of the pipe are going to flow slower due to friction. And you can look on Google to get the details on that, but at least this right here will give you a ballpark. So I thought that was kind of fun figuring out.